All right, up next we got context problems. So I left you all my hints of what I would like you to do when you are drawing out the diagrams for your context problems. And so I want to go through those 4 steps right now on this first context problem about Samory. So here's what we know. We've got good old Samory sitting on a park bench, looking up at a balloon that's in the sky. So there's a balloon in the sky. There's what my balloon looks like that a small girl accidentally let go of. So small girl. And it is floating away straight up into the sky above the girl. So those are the relevant things that are involved in this picture. So when I drew all of my relevant objects, those were the relevant things. There's Samory, there's a balloon, and there's a girl. The next thing that I want to do is I want to draw in any known vertical or horizontal lines. So for example, the ground that both Samory and this girl are standing on is a horizontal line that I'll want to draw. And let's actually put this little girl on the ground. There we go. Next, I want to add in any given measurements, including the unknown. So here's what I know. I see a 20 meters, I see a 37-degree angle. So let's make sure that we put those 2 on our diagram. And we also want to know how many meters above the girl's feet. Sorry, let me write that in. The balloon is currently. So Samory knows that he is 20 meters away from the girl, so this distance right here is 20 meters between Samory and the girl. He also knows that the angle of elevation from his feet, so from his feet to the balloon, is 37. So his feet to that balloon, he knows that that angle of elevation going up from that horizontal is 37 degrees. And what we want to find is how many meters above the girl's feet is the balloon. So this is the question mark, or the thing that I want to know. And the last thing that I want to do is I want to find the right triangle. I know for a fact vertical and horizontal lines are perpendicular. So let's go find any vertical and horizontal lines and make them perpendicular. I have a horizontal line for the ground right here. I've got a vertical line to measure the distance or the height of that balloon above the ground. So I've got a right angle right here, which tells me that the right triangle that I'm trying to find in this case is, well, that one right there. So let's draw out that triangle off to the side and put the labels on it that we know. Here's a 37-degree angle. This is 20 meters. And I'm solving for that x. So I'm going to just erase this so that I have space to do my work. So if I'm trying to solve this problem now, I'm solving for that missing side. I know my angle theta is here. I've got an adjacent side and an opposite side, so I'm going to use tangent. Say tangent of 37 degrees is x over 20. And then I'm going to, solve x. Solve and get x by itself by multiplying by 20 on both sides. And I find that 20 times tangent of 37 degrees is equal to x. Or, if you put that into a calculator to find the exact answer, 20 times the tangent of 37 degrees, 20 times tangent 37, x is approximately equal to 15.07. And then don't forget to include the units. So 15.07 meters in this case.